So brief. So basically, I am investigating how we trace concepts throughout UML class diagrams to understand how they evolve over time. And the specific domain that we're looking at for this is on free and open source software. So this is the one of the chapters of my thesis that I'm looking at. I do look at concept traceability across all artifacts, and UML class diagram is my focus for this one. So the research motivation and questions, basically, these are the main reasons why we want to do this in the first place. The UML diagrams that we look at specifically for class diagrams, they do document object-oriented design and also documentation. So because we look into class diagrams, we look into specific components of this artifact, specifically on actors, properties, and also relationships between the classes. So there is a research gap. UML diagrams and how they evolve have not been widely and extensively being researched at the moment, and even more so in open source software projects. So at the moment, this is actually an extension of, I think it was a 2017 paper back in Models 2017, where there was a data set of a very large data set of all open source, free and open source UML diagrams that existed in GitHub. So understanding how it has evolved over the past 7 years was a key focus in the work that we are doing at the moment. So we use concept tracing, and I'm going to explain more about what that means. And what we were looking at is what we call the dormancy phenomenon. So dormancy, the root word being dormant, meaning it just stays as it is. It's stagnant. It doesn't move. It's not dynamic. It does not evolve. So this is what we are looking at to understand whether or not they do remain static, although code changes and evolution does happen in all the other artifacts. And UML class diagram, we want to investigate whether they do evolve and go through the same changes and whether they do get updated throughout the years. So what we looked at, I did mention about the data set that was back in 2016, actually, back in 2016. Apologies for that. That was back in 2016. This was presented as what we call the Linorman dataset. I think I butchered the name, but that's what it is, version 2. So we had about 24,000, close to 25,000 projects then. So ever since then, the dataset has not been updated at all. What we did was we looked into how much of these diagrams were still relevant and were still existing and available. So there were 5 filtering steps that were done. If you want to know more, you can definitely go ahead and read the paper about how those filterings were done. What we did get at the end was 81 projects that had about close to 1,000 diagrams. Now, specifically, we look into graphic UML files. I do understand. So this is a big limitation that we don't look into markup languages files. However, we did want to understand about how these have been evolved. So this is one of the key focus that we did ensure that it wasn't compromised. So we looked into whether or not the projects were still active. Was there any kind of activity done in the recent year? That was one of them, and we sampled it based on that. So from the 489, we looked into 216 projects from then, and that's when we gathered at the final one was a sample of close to 1,000 diagrams. So concept extraction and tracing, basically what it is if you think of it like a converting to a JSON, that's the easiest way for me to explain it. However, it is a 3-step process that involves computer vision, where we basically identified all the classes and properties in every UML class diagram and explain that in a relationship. So it's kind of like converting back into a markup language. However, for uniformity, we looked into keys and value pairs that could be used for understanding the concept that could be extracted. So there was a 3-step process where we looked into extracting by using prompt engineering. So we were using the open source mini CTM model. Some of you may have been familiar with this. And also we validated it was 2, a technical validation and a manual validation. Validation by machine to ensure that it's structured correctly. And also there was human in the loop in the process as well. So the authors were manually checking the output files from both the agents, and we did do scoring for both of them. So if you look at the right, that is basically a rough idea of how we converted from a UML diagram into a JSON script. So what we gathered was that if we just look at the overall update of these data set, there is a huge increase of diagrams that were included in the same repositories that were part of the 2017 data set. So from 2017 to 2024, there was a 192% increase. So generally, we can see that there are a lot more diagrams being added on. So the projects did grow from an average of 3.1 diagrams each repository to 9.1. 63 of them had at least one diagram increase. So that's some of the statistics there about how much increase there is. So that was just one part to just understand about the data set and how much more, so I say how many more UML diagrams that we had. So we looked into outlier sets. So outliers are based on two metrics that we looked at. One of the outliers is on the UML and line of code ratio scaled. So that basically gives a rough idea of the size of the code base against the number of UML diagrams there is. So that's the first outlier. The second outlier is on the number of stars. We purposely chose these metrics because we wanted to understand whether the characteristics of these two, being the ratio and also the number of stars, give any kind of impact or any kind of result into having the UML also evolving together with the code base. So for the first sets, there was no evident evolution or maintenance of any of the UML class diagrams since 2017. So that was for the first set. The second set, so we looked into stars. Well, there was a paper that talked about this, which looked into the popularity of any repository does correlate to the quality. However, obviously that is very highly contested. But it was a very straightforward and simplistic metric to use to identify the popular repositories. So there were 3 projects that have been updated, and we could see at the bottom there the 3 ones that had an update of the UML class diagrams together with the other metric, which is UML log ratio scales. So out of the 3, you can see these are some of the findings that we had. Apache's Wiki, for example, there were 4 diagrams. There were some duplicates. However, there are still no updates. We did see a format change, but that's as far as how much update there actually is. The second one, Log4j, there is one updated. However, again, that is a simple optimizing of an image. So no changes in the concepts or anything that were being maintained. The third one, Pine Source, there was an increase. However, automatically, inherently, it wasn't an update in terms of any of the features or concepts that have been updated. It was more of a security update. So there was a slight change in one of the security aspects of the software, and it was changed. So this was a part of the investigation that we had. It was more or less sort of showing how UML diagrams do not necessarily, we couldn't find any evidence of how UML diagrams were maintained in free and open source software. So basically, we do find there is a disconnect in how UML class diagrams are inherently abandoned after the first part of the documentation, usually in the design part of the software. There is a call for a need of how we should synchronize these diagrams with the code. So that means incorporating it into pipelines, reducing the maintenance burdens. There is also a couple of other papers that looks into UML class diagram maintenance, specifically looking at the burden of the UML class diagrams to be updated. So normally, do we put it on the developers? Do we put it on the designers? Do we put it on which stakeholders? The thing about these free and open source software is that normally there is no specific structure to how we evolve and maintain these artifacts. So this is something that we should definitely look into. So we should think about triggers for how we can update UML diagrams. There is a lot that we talk about in terms of the benefits. However, in the paper, I did talk about how we try to balance between the cost and also the benefit of updating UML diagrams. Developers do feel that they are normally pressured to ship the next feature working agile, for example. So normally documentations like UML class diagrams are not really high up the priority list. So studying how the attitudes and perceptions about why should they actually consider even maintaining UML diagrams is also a research direction to consider. Also, not to mention what is the cost of not updating UML diagrams in free and open source software? So normally we do see these diagrams in the wiki, in the README that shows the system design, also some of the behavioral design. However, it is very much a more surface kind of analysis that we could see that it was somewhat not entirely being maintained and evolved. So the impact is what we do want to look more into about how does it actually affect maintainability, or whether it should even be considered, or whether it's an evolving field that documentation of UML class diagrams specifically is being overstated in its importance to ensure that it's being maintained and evolved together with the software. So that's a lot of questions there for future directions. However, this paper really does mostly contribute to the previous data set, updating that data set, refreshing that data set, and looking into how it has evolved, or even any of them have evolved over the past years. So thank you very much. It was a short paper, actually. So I think I'm on time, and I think it should be a good few minutes for questions as well. Thank you very much.
Thank you.